Hello, Algebra 2 students. Hope this Monday's finding you nice and cozy in your house, nice and warm. Today's lesson on 8.3 is getting into what's called a logarithm. And a logarithm, in short, is an exponent. The logarithm is the inverse of an exponential. So the book starts out in example 1 looking at earthquakes, and I invite you to read that example over whenever you get a second, and that's on page 438. We talk about Richter scale with earthquakes, and so that idea is E for energy times 30 as the base, and then the number that's raised, the power that's on the 30, that's the Richter scale value. So when they do these problems and you want to compare something that had a Richter scale of 7 compared to something that had a Richter scale of 3, we actually are doing multiples of 30. So it's 30 times bigger each time we go up by 1 on the exponent. So we would use the division property to find out how much more this Richter scale of 7 earthquake would be compared to the Richter scale of 3 for this other earthquake. And so that ends up, we do 30 to the 7 minus 3. We use that division property, and we get 30 to the 4th. So it's only 4 bigger on the Richter scale, but that actually means 30 to the 4th, or it's 810,000 times more powerful, or more energy was released with a Richter scale of 7 earthquake compared to a Richter scale of 3. And then the next part of the lesson just gives us a definition. What is this idea of logarithm? So if we are given y equals b to the x, very simple form of an exponential function, then this could be rewritten in logarithmic terms by doing log of base b, so log's the abbreviation for logarithm, of y is the x. In other words, when we do a log of some number, we're actually finding out the power we're raising the base to get that number. And that is one of the harder definitions that we have. There are a couple of restrictions, like many times. The b can't be 1, or we would just have a straight line. And also the b must be positive, so no negatives there. And the y will also always be positive with this. And so one way that I help myself remember this is I take a real simple exponential statement, and that would be 10 squared equals 100. If I was going to write this in logarithmic form, then the 10 is the base, so I would do log base 10 of this 100 number is 2. And so if you just go back to this idea, whenever you're getting turned around, on this idea of logarithm, go back to this basic fact. You know 10 squared is 100, and so that 10 is the base, the 2 is the exponent, and the 100 is the number we're getting when we raise the base to that exponent. That's the idea of logarithm. It's basically undoes exponents. So this x, we can get it down out of the exponent, which helps us solve problems eventually. So the first part of this lesson with logarithms is just, can you change something that's in exponent form into logarithmic form? All right, so the first type of problem we're going to work with this definition is changing something that's in exponential form into logarithmic form. So remember, the base goes underneath that log word. So you do log base 5, and then 25 is the number we're doing it of, equals 2. So that's telling us that 5 squared equals 25. So notice the 2, that's the exponent. That's when we do the log base 5 of 25, that's what we get. We get 2. I did another one here. 729 equals 3 to the 6th. So the base goes down below. So that's like a subscript. So log base 3 of the number gives me a 6 for the exponent. Notice that exponent now is not in the exponent location. It's down on the regular level as our other numbers in the equation. That's the goal for logarithms, is to get that variable, when it's a variable up there in the exponent, down where we can do our normal solving. All right, here's another one to give a try to. 1/2 to the 3rd equals 1/8. So you have fractional bases. As long as they're positive and not 1, that's fine for the base. And then we're doing that of this number 1/8. That would be our y value, getting our x of 3. So 1/2 raised to the 3rd power gives 1/8. Then I do one more of these here. So I've got base 10 again. Log base 10 of 1 is 0. If we do 10 to the 0, we get a 1. And just so you know, when we talk about common logs, that's base. And when we get to graphing and using our graphing calculator, there's a log button on it that is for base 10. So it doesn't say it on the button, but it's assumed that's base 10. You might be wondering, what is that ln right underneath it? And that ln is a natural log. We'll get that in a different lesson. And a natural log, that is base e. So if you remember that e number from Euler, that's where that's going to come into play. All right, third example here now is, given it in logarithmic function, can you put it back into exponential and or figure out what it is? So here's log base 8 of 16, and you're asked to evaluate it. Since it's base 8, I can't just type it into my calculator, so I'm going to have to rewrite it as an exponential. So that would be log of base 8 of 16 equals x, say. So then it would be 8 to the x equals 16. Now these don't have common bases, so to work this out, it'd be better to get these to have the same base. And both of them have a bunch of 2's in them, so I'm going to make this 2 to the 3rd to the x equals 2 to the 4th. And then the 2 to the 3rd to the x, that can be just 2 to the 3x equals 2 to the 4th. And now, because we know these things are supposed to be equal, because they have the same bases, now I can just say, all right, well then 3x would have to equal 4. And then divide away the 3, and that gets me my exponent of 4/3. You can then check by doing 8 to the 4/3, and indeed that gives us 16. All right, let's try another couple of these. So here's another one. So this would be example 3, part B. So just the second one of these. How about log base 3 of 81? What does that equal? And so that would be 3 to the x equals 81. They aren't the same bases, but I I know there's a bunch of 3's in 81. 3 to the x then equals 3 to the 4th. There's 4 3's in 81, and so that gives me x equals 4. And then the last one of these, try this one. Log base 64, 1/32. So using that definition of logarithm, 64 to the x, if I have that equal to x, 64 to the x equals that 1/32. 64 and 32, they're all made of 2's, so I could change this into 2 to the 6x. 2 to the 6th is 64. And then this one's a little tricky. Remember, it's a fraction, so that's actually be 2 to the negative 5th. There are 5 2's in 32, and so to jump the line, it's going to be 2 to the negative 5th. And then I can set these two exponents equal since they have the same base now, and so we get 6x equals that negative 5. Divide away the 6, which gives us then x to be negative 5/6. And again, you could check that. Does 64 to the negative 5/6 give you 1/32? That's a 6 there. And yes, it does. All right, next part is graphing then. So can you change things from logarithmic function to exponential and vice versa? That's the first part of the lesson, so understanding how logs work. And then secondly, let's do some graphing of them. All right, so 2 graphs to go here. Let's say they give us, for this next one, this will go with example 5s, whoops. And they give us y equals 2 to the x, and they want us to graph y equals log base 2 of x. These two functions are inverses of one another. So if I graph and get ordered pairs from this first one, then I can just switch the x and the y to figure out the new graph. So I'm going to just pick some easy x's and y's for this first one. Remember, with these exponentials, we definitely want to have some negatives and some positives as we do this. So 2 to the negative 2, that is 1/4. 2 to the negative 1, that is 1/2. 2 to the 0, that is 1. 2 to the 1 is 2, and 2 squared is 4. So now I can figure out my x and y's for this equation. And that I can do by simply just flipping the x and y. Remember, inverses have the x and y interchanged, so we can use that to quickly figure out ordered pairs for our new logarithmic function. And so I'm just going to take the y column and make it the x, and take the x column and make it the y. And then I'm going to graph those. So let's see if I have enough room over here. Graph like this. Have each square be worth 1. So this first function, the exponential one, it goes through the y-intercept of 1, and then it goes to 2, and then 4. If we did 3, it would go all the way up to 8. 6, 7, 8. If we go to the negatives, that gives us 1/2, then 1/4, then 1/8, etc. So this is our typical exponential growth curve. Notice it has a y equals 0 asymptote. And now I'll graph the other one in red here. So now I've got 1, 0, 2, 1, and 4, 2. And then I have 1/2, -1, and 1/4, -2. And if I had a 1/8, it would be a -3. And so now this is your typical logarithmic curve. Looks very similar to that square root of x graph for radicals, except now it has x equals 0 asymptote. So the y-axis is where it gets closer and closer to 0. When it was the growth, it was the x-axis that it got closer and closer to 0. So that is the basic form or look of a logarithmic function. You can find it quickly by just reversing the x and y values when you write the corresponding exponential function. Then the last thing that the book covers in this lesson is doing translations with this stuff. So for example, if we had the equation y equals log base 3 of x minus 3 plus a 2, that's going to be really hard to calculate. And so what I like to do is go to the very basic corresponding exponential function. It's base 3, so that means it's just going to be 3 to the x. And I'm going to do my chart again for the x's and y's. And again, I like to use some negatives to get both sides of the curve. And then I'm just going to put -2 in for x. I get a 1/9. Put a -1 in there, I get a 1/3. Put a 0 in there, I get a 1. Put a 1 in there, I get a 3. And put a 2 in there, and I get a 9. And now this will allow me to figure out, do this in green here. Just this basic log base 3 of x. I'm going to do the slide later. So I'm going to do the same x-y interchange trick that I did in the previous one. So now, when the x is 1/9, I get a -2. When the x is 1/3, I get a -1. 1 gives me a 0, 3 gives me a 1, and 9 gives me a 2. So all I did was switch the x and y's. So what was the y in the original exponential function now is the x in the logarithmic function. And now the last thing is to do that slide part. So this is the y equals log base 3 of x minus 3 plus 2. And so now when I do this chart, for my x's, because I'm sliding 3 to the right, I've got to add 3. And then for my y's, because I'm adding 2, that's sliding it up 2. So I'm going to take the green column and add 3 to the x and add 2 to the y, and that will get me ordered pairs that are on this red equation here. So I get the 1/9, add a 3 to it because it's sliding a 3 to the right. That gives me 3 1/9. And then the 2, I add to the -2, giving me 0. So that 3 1/9 and 0 is one of the ordered pairs on this graph. And I'll do the same thing. So this will be 3 1/3, and that gives me a -1 plus 2. Whoops, gives me a +1. Forgot to add the 2 there. Now I'm going to add 3 to 1. I get 4, and then I'm going to add 2 to the 0 and get 2. Add 3 to the 3 and get 6, and then add 2 to the 1, we get a 3. And then I'm going to add 3 to the 9 and get 12. And then I'm going to get 2 plus 2 giving 4. And then I'm going to graph those ordered pairs. So again, let's see if I can get this to fit in here. So my exponential one goes through 1. 1 gives me a 3, and 2 gave me 3, 6, 9. And then negative 1 gave me a 1/3, and then a 1/9, and then a 1/27. So there's my typical growth for the inverse of this. Then my green one, I'm going to go at 1, 0, 3, 1, and 9, 3, 6, 9, and 2. And then these little guys, 1/3 is a negative 1, 1/9 is a negative 2, getting almost to that asymptote of the y-axis there for the logarithmic one. So that curve looks like that. Whoops. And now the slide, notice that we're going to get these points slid over 3 and up 2. So if I start with this first one here, 3 and 1/9, 1, 2, 3 and a 9th, that gives me 0. So there's the x-intercept. Then 3 and a 1/3, just a little bit further, gives me a 1. Maybe about there. 4 gives me a 2. Let's see, 3, 4, 2. 6, 4, 5, 6 gives me a 3. And 12 out here gives me a 4. Let's get to these littler guys. So that's basically just going down like that and up like that. So it's slid at 3 to the right and 2 up. And that's the lesson. Hope that's helpful. Have a good day. I'll put the answer key up tomorrow. Take care.